A trader was selling eggs on the roadside. A drunk person who didn't have much work to do passed by the trader. He lost his balance and hit the cart. All the eggs fell and spilled over the ground. People nearby gathered around them as the two got into an argument. The trader shouted at him, "Can't you see? You have spoiled all my eggs. What will I do now? You have ruined my day. From where will I earn for the day? Who will feed my family today? You have to come along with me to the panchayat. You also have to pay for my broken eggs." The trader was extremely upset. He took the drunk person to the panchayat. At a moment's notice, as they reached, the trader started shouting, crying, and wanting the former to compensate him for his needs. The head of the panchayat said, "First relax and stay calm. Now tell me what exactly happened. Why are you so disturbed?" Trader tried to calm down and narrated the whole incident to the panchayat. "Sir, he broke all my eggs. I haven't even earned a penny yet. He has to pay me for my loss." He requested the panchas to compensate him for his losses. The head of the panchayat asked the trader how many eggs did he have. Trader responded, "If counted in pairs, one will remain. If counted in threes, two will remain. If counted in fours, three will remain. If counted in fives, four will remain. If counted in sixes, five will remain. If counted in sevens, nothing will remain. And my basket cannot accommodate more than 150 eggs." The head of the panchayat said, "This is a puzzle. We will try to solve it. Let number of eggs be A. Also A is less than equal to 150 according to the question. If counted in 7, nothing will remain. Therefore A is equal to 7p plus 0, where p be any natural number. Hence A is a multiple of 7 and A is less than equal to 150. If counted in sixes, 5 will remain. Therefore, A is equal to 6q plus 5, where q is any natural number. If counted in fives, 4 will remain. Therefore, A is equal to 5s plus 4 for some natural number s. If counted in fours, 3 will remain. Therefore, A is equal to 4w plus 3 for some natural number w. If counted in 3, 2 will remain. Therefore, A is equal to 3u plus 2 for some natural number u. If counted in pairs, 1 will remain. Therefore, A is equal to 2t plus 1 for some natural number t. Head is thinking and says, in all the above cases, we have A and positive integer b. In our problem, b takes values 7, 6, 5, 4, 3, and 2. On dividing A by B leaves remainder r is equal to 0, 5, 4, 3, 2, 1. The number which are divisible by 7 in between 0 to 150 are 7, 14, 21, 28, 35, 49, 56, 63, 70, 77, 84, 91, 98, 105, 119, 126, 133, 140, 147. Starting from 147, divide it by 7. We get 147 is divisible by 7. Therefore, A is equal to 147. This implies A is equal to 7 into 21 plus 0 satisfies our condition. But on dividing 147 by 6, it leaves remainder 3. Therefore, A is equal to 6 into 21 plus 3. This does not satisfy our condition. As the question says, on division by 6, remainder should be 5. But here, remainder is 3. This is not possible. Therefore, A is equal to 147 is not possible. Now, take next number 140. Divide 140 by 7. We get 140 is divisible by 7. Therefore, A is equal to 140. This implies A is equal to 7 into 20 plus 0 satisfies our condition. But on dividing 140 by 6, it leaves remainder 2. Therefore, A is equal to 6 into 23 plus 2. This does not satisfy our condition. As the question says, on division by 6, remainder should be 5. But here, remainder is 2. This is not possible. Therefore, A is equal to 140 is not possible. Now, take next number 133. On dividing 133 by 6, it leaves remainder 1. Therefore, A is equal to 6 into 22 plus 1. This does not satisfy our condition. As the question says, on division by 6, remainder should be 5. But here, remainder is 1. This is not possible. Therefore, A is equal to 133 is not possible. Now take next number 126. On dividing 126 by 6, it does not leave any remainder. Therefore, A is equal to 6 into 21 plus 0, which is completely divisible by 6. This does not satisfy our condition. As the question says, on division by 6, remainder should be 5. But here, remainder is 0. This is not possible. Therefore, A is equal to 126 is not possible. Take next number 119. Divide 119 by 7. 119 is completely divisible by 7. Therefore, A is equal to 7 into 17 plus 0, which is completely divisible by 7. This satisfies our condition. Divide 119 by 6. On dividing 119 by 6, leaves remainder 5. Therefore, A is equal to 6 into 19 plus 5. This satisfies our condition. As the question says, on division by 6, remainder should be 5. Therefore, A is equal to 119 is possible. Divide 119 by 5. On dividing 119 by 5, leaves remainder 4. Therefore, A is equal to 5 into 23 plus 4. This satisfies our condition. As the question says, on division by 5, remainder should be 4. Therefore, A is equal to 119 is possible. Divide 119 by 4. On dividing 119 by 4 leaves remainder 3. Therefore, A is equal to 4 into 29 plus 3. This satisfies our condition. As the question says, on division by 4, remainder should be 3. Therefore, A is equal to 119 is possible. Divide 119 by 3. On dividing 119 by 3 leaves remainder 2. Therefore, A is equal to 3 into 39 plus 2. This satisfies our condition. As the question says, on division by 3, remainder should be 2. Therefore, A is equal to 119 is possible. Divide 119 by 2. On dividing 119 by 2 leaves remainder 1. Therefore, A is equal to 2 into 59 plus 1. This satisfies our condition. As question says, on division by 2, remainder should be 1. Therefore, A is equal to 119 is possible. So, A is equal to 119 is possible, hence number of eggs are 119. A is 119 divisible by positive integer b, where b assumes values 7, 6, 5, 4, 3, 2. On dividing 119 by 7, 6, 5, 4, 3, 2 leaves remainder 0, 5, 4, 3, 2, 1. Therefore, number of eggs are 119. Trader feels happy by the